Hey guys, in this example, we're looking at a limit that approaches infinity. So if I were to plug infinity into this guy, I would get a well, I'd get infinity. And then if I plugged infinity down here, I would, what, I get like a negative infinity. So we have an indeterminate form. And that would tell me, hey, go to L'Hopital's rule. That's an option. I know you guys can evaluate this using your rules that you learned with rational functions and how you have the same degree in the numerator and denominator. So the limit as we approach infinity is like it's in behavior. So you'd look at the coefficients 4 and negative 3, and you'd get a negative 4/3. I know you could do that, but I'm just showing you another way. So because it would give us an indeterminate form with direct substitution, I could use L'Hopital's rule. And that, remember, that says derivative of the top over the derivative of the bottom. So if I did the derivative of the top, I would have 8x minus 5. And if I did the derivative of the bottom, I would have a negative 6x. So if I plugged infinity into that, I would still get infinity over negative infinity. So it's still in an indeterminate form. So that means I could use L'Hopital's rule again. So use L'Hopital's rule again. So if I use L'Hopital's rule again, the derivative of the top this time would be 8, and the derivative of the bottom is a negative 6. There's no x's left to substitute, and 8 over negative 6 can be reduced to be negative 4/3. So I do get the same answer. It's just another way for you to do it.